Hey everyone, hope you're doing well today. In this video, let's take a look at some application questions with fractions. So for this first question, we have 4 people and they're going to share 3/4 of a giant cookie. Maybe 1/4 is missing because I ate it, I don't know. The question is how much of this 3/4 of a giant cookie will each of these 4 people get? Okay, so we're taking the 3/4, that's what's left. That's the entirety that these 4 people can share. We're splitting it between those 4 people, so dividing by 4. Keep in mind when we are dividing, we can also say that we can keep and then change and then flip this, or we can say that division is the same thing as multiplying the first fraction by the reciprocal of the second fraction. So what is 4? Well, 4 is going to be 4 over 1. So when I flip it, it's going to be 1 over 4. Okay. On top, 3 times 1 is going to be 3. On bottom, 4 times 4 is 16. So originally there was 3/4 of a giant cookie, but when they split it 4 ways, everybody gets 3/16 of a cookie. And hopefully that makes sense, because if one person gets 3/16, the next person gets 3/16, the next person, same thing. And the fourth person, if you add up all their parts, 3 plus 3 plus 3 plus 3 is going to be 12/16, which ends up being 3/4, which is what they had to begin with. Okay, moving on to number 2. Question here is Devin wants to split 2/3 of a candy bar into 3 equal portions to eat over the next 3 days. The question is how much will he eat each day? Okay, very similar question where we have 2/3 of a candy bar. Maybe some of it was already eaten, and we're splitting this into 3 portions because he wants to have a little bit each day. And so if we want to keep this, change this, and flip this, we can change this to a multiplication problem. So I skipped one step in the last one. I didn't write it out, but I'll write it out this time. So 3 is 3 over 1, right? And what did I do? I kind of did this behind the scenes in the last one, but I multiplied and I flipped it. So I'm just showing you one extra step here, but make sure you do change it to an improper, this 3 to 3 over 1, before you flip it to 1 over 3. Then on top, 2 times 1 is 2. Then on bottom, 3 times 3 is 9. So if Devin wants to split this evenly, each day he's going to have 2/9 of the candy bar. And of course, you want to check this then. If day 1 he has 2/9, and on day 2 he has 2/9, and day 3 he has 2/9, then altogether for 3 days that's going to be 6/9, which is equal to 2/3. So that equals the original candy bar. So that makes sense. For number 3, Jaden is going to eat 1 3/4 cookies every minute. The question is exactly how many cookies will he have eaten in 3.5 minutes? Okay, so if anything's being done in repetition, we can use multiplication as a shortcut, especially if the rate's not changing. So it's 1 3/4. We could add this 3 times and add half of it the last time, but we can just multiply that by 3.5. Okay, and if we turn this into improper fractions, then 1 times 4 is 4 plus 3, that's going to be 7/3. And then if we're going to change the second fraction, 3 times 2 is going to be 6 plus 1 is going to be 7. So it's going to be 7 over 2. Unfortunately, we can't cross cancel. I know the 7s might be tempting for some people because they match, but they're both on top, so we can't. But 7 times 7 is 49, and 3 times 2 on bottom is going to be 6. Then as a mixed number, 6 times 8 is 48, and we are 1 away from 49, so it's going to be 1/6. So altogether, it's going to be 8 1/6 cookies in 3.5 minutes. Okay. If multiplication seems a little bit confusing at all, this can hopefully make sense. So in the first minute, Jaden would eat 1 3/4. In the second minute, he would eat another 1 3/4. In the third minute, he would eat another 1 3/4. And in the last bit, he's going to eat half. He's going to eat half of that. So half of 1 3/4. So you could do it this way too, where you go ahead and add for the first, second, and third minute, and then add on half of that afterwards, but you're gonna have to multiply. But this would probably take a little bit more work, but just showing you the repetition, which multiplication is a shortcut for. So if you solve that, you will also get this 8 1/6. Check out number 4. A huge rectangular cookie, okay, has an area of 2.5 square meters. This is really big of a cookie. If you know the length of the cookie is 3/4 of a meter, the question is, what's the width? Okay, so what do we know? We know the area is 2.5 square meters, and we know the length of the cookie is going to be 3/4 of the meter, and we don't know the width. The width we do not know, so it's important to kind of know what that is. The formula for the area of a rectangle is area is equal to length times width. And I also like to just kind of sketch so we know what this is looking like. So we have this giant cookie here, and inside we know the area is equal to 2.5. I'm just going to leave off the units for a moment. And we know the length is going to be 3/4. I'm going to put that over here. And the question is what is the width? Right? So if we know the formula for area is equal to length times width, we can make some substitutions here and say, okay, this area we know is equal to 2.5. So let's take this area here and make that 2.5 meters squared. And then what else do we know? We know the length. So this length over here is 3/4. So we're going to go ahead and substitute that in. So I'm going to write 3/4, and that's meters. And we're going to multiply that by the width, which we don't know what it is, right? And so if you want to find the width on its own, what are we going to have to do? We're going to have to use the division property of equality and divide this side by 3/4 meters and divide this side by 3/4 meters, right? On the right side, these 3/4 over 3/4 is just going to equal 1. So that's just going to be 1W, or the width is equal to. We can leave off the 1 by the identity property. And on the left side, this meters and meters squared are going to cancel out, right? The top has meters times meters, but the bottom just has meters. So we're going to just get one dimension when we divide. And what we really have to do is just take this 2.5 and divide by this 3/4 to find out what the width is. So 2.5 divided by 3/4. 2.5 is the same thing as 5/2. So I'm just going to rewrite it as an improper fraction. Then if we keep, then change, and then flip, we can go ahead and multiply by the reciprocal. So that's 1 and that's 2. 5 times 2 is going to be 10. 1 times 3 is 3. So we have 10/3. 3 goes into 10 3 times with 1 left over. So that's going to be 3 1/3. So the width here is going to be 3 1/3 meters. So the question is, what's the width? The width is going to equal 3 1/3 meters. Put a little dash there so that doesn't look like a variable, hopefully. Maybe it looks like -m. Hopefully you know what I mean, though. If you want to check this to make sure it works, right, then we can say this 3/4, the length times width, the answer we got was 3 1/3. Hopefully that equals 2 1/2, right? If it divided, then we should be able to check to multiply. And if you do this, this would be 3/4 multiplied by 10/3. And these 3's will cross cancel. The 4 and 10 can cross cancel to make 2 and 5. And then so 1 times 5 on top is 5. 2 times 1 on bottom is 2. 5/2 is the same thing as 2 1/2. So that does work out. Cool. Number 5. There's 12 1/2 cups of lemonade left. Bence wants to split it up, so we know we're dividing, right? Into 15 portions. Okay, so how much will each person get? So each person's going to get a portion here. So we have 12 1/2, and we're splitting it into 15 portions. So divide by 15. Let's go ahead and change this into an improper fraction. So 12 times 2 is 24, plus 1 is going to be 25. So this is 25/2 divided by, what's 15 as a fraction? That's 15/1. And then if we keep, change, flip, this is the same thing as 25/2 times 1/15. Then I think we can cross cancel, right? This 25 and 15 can both divide by 5. 25 divided by 5 is 5. 15 divided by 5 is 3. Then multiplying 5 times 1 on top is 5. Then on bottom, 2 times 3 is going to be 6. So each person here is going to get 5/6 of a cup of lemonade. So almost a whole cup, which is pretty good. Hopefully it makes sense. The answer is less than 1 because if we wanted to give 12.5 students lemonade, everybody would get a full cup. But since there's 15 portions, not everybody can get a full cup of lemonade. Number 6, we have if 30 students each got 2/3 of a cup of milk. The question is how many cups of milk was there in all to begin with? Okay, so if everybody got a full cup, there would be 30 cups, but everybody got less than a full cup. Everybody got 2/3, so there should be less than 30 cups. I'm just like making sure I understand that the answer can't be over 30. So what we can do for this problem is 30 people each got 2/3 of a cup. So instead of adding 2/3 30 times, multiplication is a nice shortcut. So that's 30 is 30 over 1 multiplied by 2/3. We can cross cancel this 3 and 30, make it a 1 and a 10, dividing them both by 3, which is their GCF. Then on top, 10 times 2 is 20. On bottom, 1 times 1 is 1. So this would be 20 total cups. Okay, hopefully that makes sense. If you take 20 divided by 30, the zeros cancel out, and that's just 2/3 anyway. Number 7, how many 3/4 cup servings of milk are there in 2/3 cups of milk? Explain why your answer is reasonable. All right, so we're going to make sure we do a little bit of explaining here, and we're talking about reasonability, so we're trying to make sure our brains understand if an answer makes sense or not. Not that we're just coming up with a number, but that seems like it makes sense. So I think it really helps to have a visual. So to make my argument here and to try to explain, to convince you that of my answer here, I'm going to draw 2 rectangles that I think are relatively close in size. And let's see here, I got to do 3/4 for the first one. So I'm going to do my best to draw quarters. Looks pretty close. And then for the second one, I'm going to try to do my best to draw thirds. Okay, something like that. So for the first one, what does 3/4 look like? Well, here's 1/4. Here's 2/4, and then here's 3/4 or 3/4. And then for the second one, it says 2/3. So here's my 1/3, and then here's my 2/3, right? And if we're making a comparison here, we want to know that how does 3/4 compare to this 2/3? And it looks like that 3/4 is bigger, right? So looking at the picture, it looks like 3/4 is bigger, but if you want to make sure, you can rewrite them using their LCM of 12. So this is 9/12. And this 2/3 the same thing as 8/12. So it's actually not bigger by much, but we can see here that the 3/4 is definitely bigger than 2/3, and everything kind of matches up there, right? So if we're trying to say how many servings of 3/4 cups there are in 2/3 cups of milk, we want to make sure that we can't fit a full 3/4 cup serving inside one of these 2/3 cups, right? So that's important to know that the answer that we get here, or the number of servings, must be less than 1. That's the whole idea of the reasonability part here, right? Because fitting something that is a larger value into something that's a smaller value, it's not going to fit in a whole time. So that right there is just talking about reasonability, but if we're trying to see how many of these 3/4 cup servings fits inside the 2/3 ones, then we really are going to do a division problem here, right? And we can take this 2/3, and as we do with all multiplication division problems, we can rewrite it as a multiplication problem and multiply by the reciprocal, keep, change, flip. Unfortunately, we can't cross cancel. It looked like we could, but once we flipped it, we could not. And so we're getting 8/9. Right? So 8/9, that is definitely less than 1 because it's a proper fraction, right? Our answer is reasonable here because of the following. We knew the answer had to be less than 1 because 3/4 cup serving has to be fitting into 2/3 less than 1 whole time. Basically, I'm just going to write here and say since 3/4 is greater than 2/3, the answer must be less than 1. Because 3/4 fits into 2/3 8/9 times. If your rationale for your answer was something similar to this, then that is great. Basically, you just want to make sure you understand the comparison between 2/3 and 3/4. If they were trying to fit how many 2/3 cup servings into 3/4 cup, you should get an answer that's greater than 1, and your reasoning for that would just be that that 2/3 is less than 3/4, and so you should be able to fit more than 1 serving. All right, last problem here. In this question, it says how many half-cup servings of apple juice are there in 3/4 cups of apple juice? And we're going to explain why our answer is reasonable here. Okay, so very similar. If you felt good on the last one, then you should hopefully feel pretty good with this one, or this one will feel a little bit more comfortable. So I'm going to draw this out again. If you want to try it on your own, go ahead and pause and see if you can do it. But go ahead, and I'm going to sketch this out just so we can see what's going on here. So we have half, and we're comparing that to 3/4. All right, so here's what a half cup serving is going to look like. And then this is compared to the 3/4 of apple juice that we actually have. So we're comparing this, and we're saying how many half cup servings are going to fit if we have 3/4 cups of this apple juice. So a little bit easier to compare. Maybe this is 2/4, comparing that to 3/4. Again, once we get common denominator, it's easier to see, but 2/4 is definitely less than 3/4. So if we're saying how many half cup servings will fit into, if we have 3/4 cups of juice, I think the reasonability thing that we're looking for here is that the answer has to be greater than 1, right? Half is going to fit into 3/4 more than 1 time. That's the whole idea here, okay? As opposed to the last problem 7, where it didn't fit in a whole time, so we knew the answer was going to be less than 1. So let's go ahead and see what this is going to look like. So if we're seeing how many times half fits into 3/4, so this is the total amount of apple juice, and we want to see how many halves we can actually get out of it, then that's the division problem we set up. Then we can change, and we can flip or multiply by the reciprocal. This 2 and 4 cross cancel to make 1 and 2. Then this 3 times 1 on top is 3, 2 times 1 is 2, and sure enough, we get 1.5. So 1.5 is the total number of servings we can create here, and that's definitely more than 1. So for our explanation here, I'm just going to basically say since 1/2 is less than 3/4 or 3/4, we know that 1/2 will fit into 3/4 more than 1 whole time. Due to that, it's reasonable for the answer to be greater than 1. So there you have 8 different examples dealing with some application problems with fractions. So hopefully you found the video helpful in strengthening your understanding of these concepts just a bit more. And as always, keep up with the great work, and I will see you in the next one.